So good afternoon, everybody. I hope you're enjoying your nice break from opening day baseball. Go Red Sox, and are interested in learning about how soda is made, the chemistry perspective. So, a brief history of soda. Soda water was actually first discovered by Joseph Priestley, who is an 18th century English chemist in a brewery. And the way he discovered it was he decided to take water, regular water, and he put it over a beer vat and added CO2 to it. And he noticed that CO2 started bubbling out of the water that was forming from the fermentation of beer. And he actually used it to, he developed this idea of making carbonated water. However, soda didn't really become popular in a drink until the late 19th century, interestingly enough. So we had this carbonated water, which we'll learn about later, and we never really made it into a popular beverage until the late 19th century. So the main ingredient in soda is actually carbonated water. 94% of soda comes from carbonated water, and the way you make and as mentioned above, the way you make carbonated water is by H2O and you add CO2, and this makes H2CO3, and this equilibrium reaction occurs inside a closed soda can, and this is also what creates the bubbly taste that is in soda. So in this video that I will present to you, we will see what it is like to make carbonated water. Let's fast forward a little bit. So here we go. This guy is pouring water into a what it will eventually become an air-packed bottle. And he'll pour it all the way to the top. So he added his water, and it'll go down, and he'll add carbon dioxide right through this gun. And as you can see, he's pumping, and you can actually see the carbon dioxide when we later show it. There it is right there. As he stirs it up, you can actually see the carbon bubbles inside forming. And as we mentioned with soda, when you open the bottle, the carbon actually moves to the top. So he'll shake it again, and the carbon will actually start to form to the top. And that is basically how carbonated water is made. It's just a constant equilibrium reaction between water and carbon dioxide, and it goes back and forth. So then the next thing, one of the main ingredients in soda is high fructose corn syrup. So the sugar is actually, yes, it is produced by corn. This is the natural corn. It also comes from beets, and what is produced from the roots is crushed into a liquid, and enzymes are added, and this produces a chemical reaction. And from this reaction, we get glucose fructose, which is C6H12O6. It's actually a mixture of glucose and fructose. However, in order to make sure that it reacts with carbon, we have to react the sugar we get, which is 42% fructose and 55% glucose, and mix it with another isotope of high fructose corn syrup, which is 90% fructose. And from this, we get a fructose syrup, which is 55% fructose, 41% glucose, and 4% other sugars. And this is the other main ingredient that comes in soda, which is high fructose corn syrup. Hold on one sec. So the next thing we have is the caramel color in cola. And this is produced by oxidizing the same sugars that we actually get from this corn plant into a brown liquid. And what happens is that we take like a natural sugar and we oxidize it using fire or anything like that, and the chemicals actually from the sugar break down and they form a light brown syrup. And I don't know, you guys have probably seen a soda fountain before, but that's basically what it is. That syrup is the caramel color along with the high fructose corn syrup and any other chemicals added, and it mixes with the carbonated water. What's interestingly enough is that we've all seen this caramel color process before. Think about in the summertime when we're roasting marshmallows. The marshmallow turns out white, but it's mostly made from sugar. And what we do is when we put it over the fire, we want that nice golden brown color to show, because it tastes better like that. It's nice and hot. Well, what happens is that's brown. That's the chemical change happening. That's the sugars in the marshmallow being oxidized to form this golden brown marshmallow shown here. The acidity of soda, interestingly enough, is not all from the carbonic acid. It actually comes from phosphoric acid, which is H3PO4. The reason we add it is because it kills off bacteria. Bacteria actually forms in sugar solutions. So the reason this acid is because it is able to kill all the bacteria that forms. Interestingly enough, though, the pH of just a regular phosphoric acid is 2.1. On a pH scale, 7 is a neutral pH, and anything less than 7, if it goes from 6 to 5 to 4, it becomes more acidic. So imagine 2. That's like a pretty strong acid. So that soda that we're drinking, it's pretty acidic. That's what the burning sensation comes from in the taste. And unfortunately, this phosphoric acid does lead to potential problems. It has been known that people that drink constant soda usually have osteoporosis forming, and that usually is because the minerals that we have in our body, like calcium that we get from drinking milk, well, what happens is that the phosphoric acid actually binds to them and they're not able to do their job. So our strong bones that we get from the calcium, that calcium's gone. So people who tend to drink soda usually have a 4% loss in bone structure. Other potential problems that we need iodine for our thyroid to function. Well, without iodine, our thyroid doesn't function as well. And that could lead to other potential problems, as you could imagine. So the main ingredient is caffeine. This is also in the syrup. There's no real chemistry behind the caffeine in soda. The main reason it's added is to hook the buyers into drinking more and more. So it's kind of like any addiction, cigarettes, the nicotine. It said once you smoke like about 1 to 3, you become addicted. Well, that's what's said to happen with soda also. Maybe not as bad, but people do have caffeine withdrawals and they do end up getting headaches. Now, diet soda is interestingly enough because instead of using high fructose corn syrup, we use aspartame, which is C14, H18, N2O5. This is actually said to be 20 more times sweeter than regular sugar. And the way we make this is we react 2 amino acids, which are aspartic acid and phenyl. You guys can see that up there. And they bond to each other to make this amide bond, which is also known as aspartame. This also goes under different names such as Splenda and Equal. The problem that we have with this, because soda has many problems, that it has been linked to cause cancer. So people like me who are diabetic and are drinking these diet sodas, we might be more at risk, unfortunately. So fruit flavored sodas, as we mentioned above, the caramelization is how we get colors in cola. But what about beverages like Sunkist, Fanta, 7-Up, all these other different, Sprite? Well, the reason they're made is because of fruity acids, which is also mixed in with the syrup. Citric acid, malic acid, and it also contains a lot of natural flavors. It goes under the same process. Like I said, you ever go to any kind of restaurant, like fast food, Burger King, McDonald's, all that, you can actually see the carbonated water coming out and mixing with the syrup that's added. That syrup can be different colors as we imagined. And so the way we get those is by it's just the different flavors they have. So I will show you guys why you cannot shake or drop soda. So, as we mentioned above, with this bottle of root beer, what happens is that after the carbon dioxide is added to the H2O, it's packed in an airtight bottle. So when you actually open up a bottle of soda, as I will do now, that sound that you guys hear, that's actually carbon dioxide being released from the bottle. And as you can see right here, all the bubbles are forming to the top. Well, if we drop this, because the carbon dioxide and the water are mixed, it forms openly. But if we drop this like this, the carbon dioxide is, when it was on the ground like this, gets spread out all over. See, it goes from the bottom to the top. So if we open this up, the carbon dioxide is going to come roaring all the way to the top and cause that to happen. Cause it to spray all over. It's not as bad as it could be, but if you really explode it, it really explodes out. And that's because of the carbon dioxide. The bubbles are getting larger and larger, and you're not able to get the same, to have that same volume. So they'll explode faster and faster and faster at the top, and eventually they'll come right out. And so that's pretty much it, guys. Thank you guys for listening to my presentation. Here's my references, my bibliography, and my pictures. And please just enjoy it. Hope you enjoyed it, and hope you learned a lot about the chemistry of soda.